Hello guys, welcome back. Today we are going to start today Leetcode question. So from long time I have not started making the videos, right? So what I'll do today onwards, we will go with the daily series, right, of Leetcode problems, right? So let's understand today Leetcode question. So this is 1647, the minimum deletions to make character frequencies unique, right? So question is saying that we have given a string s and it is a good string, right? Why? Because there is no difference between characters, right? If there is no difference in the character that having the same frequency, okay, so in that case this is a good string. Okay, if we are going to make the string as a good string, then we have to return the minimum number of frequencies that we need to make good string, right? It means we have to delete some you can say characters from the string to make a good string, right? So the frequency of a character in a string is the number of times it appears in the string. For example, in the string AAB, the frequency is frequency of A is 2 and while the frequency of B is 1, so it's totally different, right? So for A there is differences frequency is 2 and for B the frequency is 1, right? 2 and 1. So it's good because there should be different characters and should not have the same frequency, right? As you can see that if we have a string given double AB, in that case there is no need to modify in the given string and we will return output as a 0 because we are not going to make any deletion in this string, and the number of frequency that character we need to make a delete, that is not required. Okay, that's why we are returning 0. And so it is saying that in the explanation that string s is already good string, so we do not need to worry about that. Let's understand example 2 where we have given A 3 times we have given, then we have given B 3 times we have given, and then C 2 times we have given. Okay, so here 3 and here is 3, right? So number of frequency we have given for A is 3 and for B frequency is 3 and for C frequency 2, right? So here two characters for the string A and B have the same frequency, so this is not a we can say good string. To do that, what we have to do, either we will remove from elements from A or B, right? So what we will do, let's suppose if we are going to keep A for 3 times, right? A will be 3 times frequency and B we are going to take 2 times, right? And C we will take 1 times. So this is we can say that this is a good string, right? So what we will do, we'll delete 1 from B and 1 from C. So now it's a good string, right? So we have deleted 2 number of characters from the given string, and that's why it is output should be returned 2. So you can see that we have output 2. Let's read the explanation. So you can delete 2 B's resulting in the good string, and that is we have now. And if we are going to delete from B or C, then in this case it will look like this one, right? So either I told you, either you will delete from A or B, or either you can delete from B and C as well, right? So this there can be many chances to make the string, right? The frequency number of deletion. So make sure that we have to return the minimum number of characters that we are going to delete, right? You can make a string as a good string, right? But you have to take care of that. We have to delete minimum number of string, right? So we are given string s that we have of lowercase English letter, right? And we need to delete some characters so that the frequency of each character is unique, and the length of the remaining string is you can say as long as possible, right? So we can rephrase the question that we have given a list of 26 numbers, right? You can say where each numbers represents the frequency of a lower you can say different lower English letters, right? Sorry. Make sure that these numbers are unique. We are going to decrement some by some frequency, right? So we can make unique characters, right? Note that we can only decrement a number and cannot increment it, right? However, we can delete any number of times, right? So hence, if we have to equals numbers, right, in the frequency, we will have to make one of them is similar to the them as a unique, you can say. Okay, so this is the way we have a key observation, right? We will use this in the approach, right? So what we are going to do, we will use like we will do decrement of each duplicate until it is unique, right? So what we should do, right? So so in this approach, what we will do, we will first start by calculating the frequency of each character, right? Then in this approach, we will iterate over the frequency, and for each frequency we will check to see if the frequency has already been seen, and if it has, we will decrement the frequency until it becomes unique or it becomes 0. Okay, so we will iterate over the frequency. We need to store each frequency we have seen, right? So this approach, we will ensure that we get unique frequency. But how do we know that the frequency of character we delete in the process is the minimum possible, right? So the reason is for each frequency we reduce it as few times as possible. Okay, and as we know, right, when we have multiple frequency of a frequency of a character, right, we will reduce the each frequency only until it becomes unused frequency, right? Then we will stop at that time. So if the frequency, let's suppose we have x, right, and then all the frequency we have to decrement if needed, right? So if the maximum frequency we have x, right, so all the frequency that we have to be decremented, right, if needed, to be in the range 0 to x, you can say, right? So in this case, as you can see, let's assume that this is the x that we have 3, right? So you can see it is in the decremented order. Okay, means I am saying that the range should be 0 to x, right? 0 to x, in this case 0 to 3 maximum, right? So the processing order doesn't matter, right? You can take any either 1, then 2, and then 3, like that, right? So it doesn't matter for the final result. Okay, so there are several combinations, right, we can make, and we can delete the characters, right, if required. Since the number of deletion is just the difference in the sum of the frequency before and after making all the frequency unique, we would get the same result, right? So if our final frequency, we say something we have, like let's suppose we have 3 to 1, right? So from this we can conclude that the order in which we decrement frequencies, right, does not affect the number of deletions. Okay, so what we will do, we are going to create the application, right, and let's see how to do this. So let's understand the now code sections, right, how we are going to implement this one, right? So what we will do first of all, we should as I told you, right, that there can be a 26th number, right, in the alphabet of English, right? So if we are going to store all these letters in array, and we will find the frequency, and then we will store in some array. Okay, so what we will do, let's suppose I'm trying to say this is an array that we are going to do, we are going to create, right? And let's suppose there is a frequency, right, frequencies. Okay, so I will take the frequencies array, and we can say integer, and 26 letters will be there, numbers will be there, right, in this one, right, for all the characters, right? Now what we will do, for all the characters, let's suppose we have some characters, right? So we can get the characters from where? String. So what I will do first, get all the characters dot length is a function in the string, and then I plus plus. So all the characters we will get, and how we will get that? Let's suppose frequency at frequency add we will do, and we'll say s dot char at what, there will be some number, right? So that is I, right? We will pass. If we will do minus some characters, right? Let's suppose a alphabet have 65, right? I think 65, whatever the number will be there, right? Let's suppose that is the number, and we'll do minus character s dot char at I, there will be some character, right? Minus a, there will be some frequency index, right? And we'll do that index should be plus plus if it is matching. Okay, so now you have all the characters frequencies, right, in the frequency array, right? You can say that we have stored already the frequency of each characters, right? Now what we should do, we will create a delete count if it is required, right? To check, let's suppose that is called delete underscore, we'll say count, and we'll start from 0. Okay, so we are taking a delete count, right? We will use a you can say this count, and while we are returning the data, right? So how many required we need, right? So let's suppose this is nothing but this delete count we have to return how many times, minimum number of delete count we have to do, and here we have to do the logic, right? So first of all, we will create a hash set and we'll check the which frequency we have already seen, right? So let's use a hash set, right, to store the frequency that we have already seen, right? And to do that, what we will do, we'll create a hash set like this, and this is nothing but our integer, and we can take some value, right? And that value is nothing but scene frequencies. I can give the name scene frequency, okay, or we can do like this, scene frequency. Okay, scene frequency equal to new hash set and the generic like this. Okay, now what we will do, we'll go with the for loop with the 26 characters, or you can say letters of alphabet from int I equal to 0. So total number of integer we have at the frequencies is 26, right? So less than equal to this, so I plus plus, and then we will make the loop. To make the loop, what we will do, we'll keep decrementing the frequency until it is unique, right? How we'll do that? We'll check a while loop and we'll check the frequencies at some character I, let's suppose. If it is greater than 0, and we can say and this scene frequency is there, if scene frequency dot contains what frequency, right? Frequency at I. Okay, so if the frequencies at I is greater than 0 and frequencies scene frequency contains this frequency number, right, means we have already seen, right? So what we will do, we will decrement this one. How? We will say frequencies at I will do minus minus, right? Sorry, scene frequency not, this is a frequency f, and then we will increment the delete count. Delete underscore count is there, we'll delete count and we'll say plus plus, right? So delete count is there, right? Now what we will do, we will add some newly occupied frequency to set the scene frequency, right? To do that, let's suppose we have already done this one, right? Now scene frequency we have, right? We'll do add and we will pass this frequency at I because we have updated already now, right? Let's update this. I think that's all we have to do. Okay, let's run this code. So scene frequency, okay, here we have did little wrong. Okay, oh, this is an array. Now run this. Okay, submit. It's working. So from today onwards, what we will do, we'll do hands-on on the daily Leetcode question. So please tune yourself and do little practice by your own, and then we will come to the expert funda and we'll see the solutions, right? If you have any suggestions, please let me know in the comment box. So let's understand the now complexity. So give me 1 minute. So for the complex, let me go with this one only. So we have taken the frequency here with the 26 letter alphabet, right? So if the string we have here, right, if the length of this is n, okay, so there can be a possibility, right? So if the maximum possible number of distinct character in this is, let's suppose that is k, length is n, but distinct elements or characters you can say is k. Okay, so you can say this is the maximum possible number of distinct characters or unique elements, right? So to store the frequencies, right, we need to traverse the string, right, and it will take O of n times. Okay, as you can see here, right, O of n times it will take. The maximum number of the operations will occur when the frequency for all the k characters are the same, right? So in that case, for the ith character, right, we would need to decrement the frequency by I-1 to make it unique, right, for all any ith character. Let's suppose we are going with the third character, so we will take what 3 minus 1, correct? And so that we can say the total number of operation that is required is what 0 plus 1 plus 2 and so on will go till the unique character minus 1, right? So if we will store this one, right, if we will calculate, right, so you know that the formula n minus 1 by what n by 2, n minus 1 into n into n minus 1 by 2, right? That is that complexity will come, right? So if we will check the complexity, right, this is nothing but k square, right? So finally this is the O of n and this is nothing but k square, right? That is nothing but a k square. Okay, so if we'll do the sum, right, for TC, it will become what? O of n plus k square, right, where n is the number of element and k is the unique element, right? So this is the time complexity we have. Okay, for the space complexity, we have seen that we need k indices in the list of frequency, right, here. How many, right? So we need to store that element, right? So there can be at most k unique frequencies, as you can see here, right? And so that the space required for the hash set, right, here hash set we have, right? So we are storing in the hash set also, right, as you can see here, right? So the hash set also required this scene frequency, right, as O of k element, right? O of k element, the unique elements you can say, right? So we can say this is the space complexity for this program. Okay, so guys, if you like this video, please hit subscribe this channel and please let me know any suggestions from your side, right? You can do this problem using the you can say sorting, right? So you can try by the sorting. What you have to do, just the given characters, right? This program till here it will remain same, right? Now what you can do, you can check the frequency, right, and then you update there, right? So please let me know if you are going to use by the sorting method, right? We can try, but that's all for this video, and thank you for watching this video.